The ER diagrams we've been looking at in this class use thick edges for participation constraints and arrows for key constraints. But there are other similar notations that are used in many tools for ER diagrams. A popular one is what's called crow's foot notation, and it has this encoding. If you have a little circle, that means 0 or more. If you have a vertical bar, it's 1 or more. A vertical bar with a circle is 1 or 0. Two vertical bars is exactly 1, and a little crow's foot means many. And so up on the upper right is our employees, manages, works in, departments schema. And on down on the lower left is the same schema in a crow's foot notation. And you'll see, for example, that the thick arrow of departments participating in the manages relationship is captured by the two little lines on the right-hand side of the manages line in the crow's foot notation. There's exactly one manages relationship for every department. Okay? Similarly, you can see the bold edges for works in being represented as crow's feet with a 1, which means 1 or more, possibly many, participation in both sides of that works in relationship. Okay, so crow's foot notation is just a different way of writing down the kinds of things we've been writing down up to now. It's a useful thing to know. One detail with crow's foot notation is it tends to not let you write down relationship attributes. It's sort of just to clean up the diagram. They don't have a way to do that. And of course, you could imagine extending crow's foot notation to allow little bubbles on the labels of the edges, and that would be perfectly fine. But typically, crow's foot notation skips the attributes of relationships. Here's a handy decoder for translating these constraints we've been looking at across notation. So when you have no particular constraints, in our notation, it's been just a line, and in crow's foot notation, it's a crow's foot and a 0, meaning 0 too many. When you have a key constraint in our notation, which is an arrow, in crow's foot notation, that's a 1 or 0 participation, right? You have to have at most 1 participation in that relationship. When we have a solid edge, that's a participation constraint, it says you must participate. On the right-hand side in crow's foot notation, that's a 1 or many, so it's a crow's foot with a 1. And on the left-hand side, when we have a bold arrow, that means both participation and key constraints. On the right-hand side, that's 2 vertical bars, meaning exactly 1. Now, there's terminology from mathematics for relations, which are mathematical objects, that corresponds pretty closely to the relationship sets we've been looking at here. So, for example, a relation between two sets, x and y, a relation R between those sets is called a function, or a partial function, if it has a key constraint like this. For every x, there's at most 1 y. And that's familiar to you. A function f of x can only have 1 y for every x. It's called a partial function if it's not defined on every x. But a function is a total function if it's a relationship between x and y, where for every x, there's exactly 1 y, right? A relation is described as surjective, or onto, if there's a relationship for every value in y. Okay, and that looks like a bold edge on the right in our diagrams, yeah? And a relationship Rxy is called injective, or sometimes called one-to-one, if it's essentially got a key constraint on the right-hand side in our notation. For every y, there's at most one x that maps to it. Finally, a relationship R over x and y is called a bijection if there's a one-to-one mapping of elements of x and elements of y. So for every x, there's exactly 1 y, and for every y, there's exactly 1 x. Understanding this connection between ER diagrams and terminology from abstract math might be useful for you down the road if you're communicating with friends who are mathematicians, and it just helps remind us where we came from. The relational database really is grounded in math.